The last lesson of what's been a really long unit, but has nicely simplified for us. Why can I write the function in the way that it's been written? I can clearly read off my x-intercepts. My x-intercepts are at -1, which changes it to a factor of x plus 1. I have another x-intercept at 0, which is plain old x. And I have another x-intercept at 3, which changes it into a factor of x minus 3. Now, we've been working up until this point with c values that are either 1 or -1. But it's possible that the c value is something different, and that's what we want to explore today. This graph goes through the points 2, -24. So 2, -24 is hiding under my recording. That's the minimum position. So now I actually have to find my c value, and I get to use my function notation. This says that p at 2 is equal to -24. So -24, I get to take all my x values and replace them with 2's. 2 plus 1 and 2 minus 3. So c times 2 times 3 times -1. That's -24. -24 is equal to -6c. That identifies for me that c is equal to 4. And my polynomial becomes, my p at x becomes 4 times x plus 1 times x minus 3. I should be able to generate the constant value, which is the y-intercept, which for this case is 0. It makes my coefficients a little bit awkward to have manipulated out. Let's try this skill again based on what we know concerning graphs. We're looking at intercepts that are integers, and I'm going to go for the lowest possible degree, so that's good. I have an x-intercept at x equals 2, and I've got a slide happening at x equals -2. So my factors get changed. My roots get changed into factors. X plus 2 because of that slide, that's a 3. And the x equals 2 was just a single one, so that becomes x minus 1. Now remember, we're investigating what in the world is c doing, so I have to include my c. And I've got to look for a point on the graph that has some significance. The point on the graph that has some significance, my x values, or my y values go up by 4s. 4, 8, 12, 16, 20. So I have a y-intercept that occurs at x equals 0 and y equals -8. That's going to give me a potential plug and play for my statement. Let's plug and play. So I'm plugging and playing. My x value is 0. So 0 plus 2 cubed is simply 2 cubed, which is 8. So that's going to be 8 times -1, which is equal to -8. So -8 is equal to -8c. Caught my error there on my 2. That should have been x minus 2. So 0 minus 2 is -2. The -2 hits the 8 and makes it -16. I solve for c. C is a half. And I get to say that this statement is y equals a half times x plus 2 cubed times x minus 2. Now the nice thing is you can actually check that on your calculator. We've got 2 more to try. Let's go down. So reading through class example number 3, I noticed that the graph is tangent to the x-axis at 2 points. That indicates a multiplicity. So I have an x-intercept at 2, which translates to a factor of x minus 2. And because it was tangent or bounced, It's doubled, so x minus 2 squared. And I have a multiplicity of 2 at the x value minus 3, which is a factor of x plus 3, and that has to be squared. This corresponds to the degree of the polynomial I need, which is 4, and that's going to be times by c to be equal to my polynomial. Now, function notation again, it says that p at 1 is equal to minus 12. So I get to plug in minus 12 for my p at x, and my x value is 1. 1 minus 2 squared, 1 plus 3 squared. So evaluating 1 minus 2 is 1, technically negative 1, but I had to square it, so that's 1. And 1 plus 3 is 4, and I had to square it, that's 16. And now I have negative 12 equals c times 16. So c is going to be equal to negative 12 over 16, which can actually be reduced to negative 3 over 4. Divide both top and bottom by 4. And I get to say what my polynomial is. My polynomial, which we're preferring to write as p statements, p at x is equal to negative 3/4 times x minus 2 squared times x plus 3 squared. And we'll try one more example, and then this unit will be done. So trying the translation on this. A polynomial function has the following 3 roots. Negative 2 is a root with a multiplicity of 1. That means that the associated factor is x plus 2, and it's to the power of 1. 1/3 is a root with a multiplicity of 3. So I'm going to go x minus 1/3 with a multiplicity, of 2. And then 1 is a root with a multiplicity of 3. So that's x minus 1 to the 3. Now they told me that it has a y-intercept, which gives me an xy point. When x is 0, y is 2/3. So that's going to help me discover my c value for my p at x statement. I'm not sure I want to make this look any more beautiful than it already does. I'm going to leave it as it stands and plug in 0 and 2/3 appropriately. All right, so x is 0 and my y is 2/3. So 2/3 equals c. 0 plus 2 to the 1, 0 minus 1/3 squared, and 0 minus 1 cubed. So 2/3 is equal to c times 2 times 1/9 times negative 1. Gotta watch that sign. So 2/3 is equal to negative 2/9 c. What's c going to be? So if you take a look at your manipulation for c, my c value is minus 3. Now I recognize that I've used a fraction and you may not have. Look at how my answer can be manipulated. So p at x is negative 3, that's my c value, times x plus 2 times x minus 1/3 squared times x minus 1 cubed. So that we knew, that we feel pretty comfortable with. But that negative 3, how can that negative 3 come into my statements? Does it help me? I've ran the statement with integral factors. That's how the answer needed to be presented with integral factors. So the only thing that had to change was my x minus 1/3 had to become 3x minus 1. My c value is going to change. I have an answer that looks different. And that different looking answer needs a little bit of explanation. We've struggled with that a little bit. So P at x is equal to 1/3 negative times x plus 2 times 3x minus 1 squared times x minus 1 cubed. But was my answer similar or the same? What did my answer do? My answer took 3x minus 1 and had it rewritten. It took 3x minus 1 and it converted it into this form. I had x minus 1/3, x minus 1/3 written twice. Well, how do I get x minus 1/3 from 3x minus 1? That would have had to have occurred with 2 3's. The 3 has to multiply in on the first bracket. The 3 has to multiply in on the second bracket to get my 3x minus 1 squared. Those 3's can manipulate up to the front. They can move up to the front. So now my C value with fractions as my factors, so that's what makes my first answer not as nice, would be 9/3 with a negative, with my factors written as x plus 2, x minus 1/3 squared, and then x minus 1 cubed. My answer would be the same. -9/3 is the same as -3. This is the better answer. This is the better answer because I need to write it as integral factors. So this is the better answer. Just good to have talked through factors being written in two forms. That's it for this lesson. We will work today and tomorrow on finishing off the lesson. We'll save the practice test for either our day off next week, Wednesday, or Thursday. On Monday and Tuesday, we'll actually begin to explore radicals, a unit that you're really familiar with. Thank you.